How do you make sense out of the data? That's a daunting task for any company that has so much data at their disposal. And we have just the right person to talk us through how this could be done, potentially. He's got a lot of experience in the field of data analysis. He's a data scientist. And I welcome to stage Florian Dohmann.
Yeah, hi. I thought about, okay, we talk about machines here, we talk about Industry 4.0. What is strongly related to the machines and especially the data that is created by the machines is the topic of machine learning. And here you see this five different letters, MLaas, and that means machine learning as a service. And today I want to talk about how can we use machine learning, so advanced statistics, for using and for exploring the data. And that is the task that we have at the company where I work for the Unbelievable Machine Company. And I want just to give you some hints about the great chances that we have with using algorithms from the world of machine learning. And I just want to start very briefly with explaining you what machine learning is. I'm sure not all of you know what it is, but you can see it as, or let's start with the spam filter. So all of us know a spam filter, and that is a great example of what machine learning is, a very easy example. So I train the machine what is spam and what is not spam. So my spam filter, after some time, knows by itself what a spam email is. Very simple, but you train the system. And this paradigm of training the system with data, giving it training data that the system, that the machines can learn from that paradigm or this discipline is very important for this whole topic we are talking about, because we have all this different data. You're great startups that, on the one hand, feel responsible for creating the data, plugging some hardware to machines, but then afterwards also analyzing it, because in the end it's about the business case. So in the end we have to see what can we now really do with the data that we created, and machine learning helps. You see. On the other side, there's a spam filter, but there is also a small visualization. That is a visualization that we in our company, for example, create during exploring the data. So it is a visualization that shows us clusters within the data. So that is also something very important when we talk about analyzing data, that we on the one hand train the machine, which is called supervised learning, because you tell the machine, you give the machine some information like spam or not spam, but it's also about unsupervised learning, so that the machine finds clusters, finds patterns within the data from that we can learn. So for example, when you have all the transaction data from a customer, or if you have all the log data from a machine, algorithms from machine learning can help you to find these patterns and, for example, to predict problems with the machines. Like we've heard before, that is a classical use case that the startups will talk also about, that you can predict problems that will occur on the machines. And of course, it's not an easy topic. In the end, it means something like this. So machine learning algorithms are not really usable out of the box, and you cannot really use it as a black box. So for example, another machine learning case is image recognition. And you want to classify an image. You give it an image and you want to get an answer, like, for example, is it a man or is it a woman? But these systems you have to understand, and you have to train them, and you have to understand the mathematics behind that. Here I made a small screenshot from a colleague of mine, the book laid directly on the other desk. So that is something that is very important, that all of us should not think that we can use the systems just out of the box. We have to understand them, because something like that makes it often very difficult. So when we talk, for example, about image recognition, you have to train the system that it works very well. you have to find the perfect model that the machine is able and that it is precise enough, for example, in this case, to differentiate between a dog and a girl, in this case, or between something else. Here, of course, it's just a funny picture, but in real world, we find that also very often, that we have to understand the mathematics behind that, and we have to build these models by our own, that the machine in the end really is able to solve problems like that, in this case, to identify whether it's a girl or a dog. What is also very important in this field is the APIs. I don't know how many people of you know about what an API is. API stands for Application Programming Interface, so that it means that you can use the knowledge of a system in a programmatical way. For example, IBM, for example, has its Watson. I think some of you know of it. And they released an API, an open API, where you can use the service, for example, to do image recognition or to translate a language, but in a programmatical way. And that is important. We don't want to do it manually. We want to do it programmatically. So when we have here the startups who do the analytics on the data that they collect, they want to build a software, and maybe they think about, and they should think about, I don't want to program all that again that was done previously by someone else, and that exists also in the machine learning world. So for example, that problems like translating a sentence, or for example, to give as an input a text and get a voice back, like for example when we use services that we know, for example when we use Siri on our iPhone, I say something and I get an answer. All that services are often provided via API, and we can use that, and we don't have to build it by our own. And here you see a small screenshot that is from Google, from the Google Developer Console. When I want to do a search, I can do it in the browser, and I get the results, but I can also do it in a programmatical way. And here's just a short example. It's just 12 lines of code, and you don't have to understand them. Some of you do, I think. But with these small, short 12 lines of code, I can ask Google, in this case, for code N. I search for code N, and I get the 20 top results back from Google. And then I can use these results in a programmatical way for further analytics. For example, to run machine learning on that. For example, to cluster now the results. So APIs are very important when we talk about data analytics. And that is just a small example where we stand, and that it's comparisonable easy to do it. And I brought you one sample of an API that I found very great. I think most of you haven't heard about that. Here's just a small screenshot of a list of machine learning APIs. You see, for example, on the top with number 11, I hope you can see that, face recognition. So you can push an image to the API, and you get back if it's a face or not. Or another API that I want to show you is Genie. And Genie does something very great. And I show you what. Genie, I can ask questions. And I can ask Genie questions in a programmatical way, but also I can use this API simply within the browser. The answer that Genie gives me is in a format that not all of us, or not all of you know, but it's a standard format how you communicate in the data world. It's called a JSON format. That means it's a specific form of data that is used for talking from one machine to another machine, or from a machine to a human in this case. And on the top, you see there it says input equals what's machine learning. And that's my question that I asked Genie. And Genie gives me an answer that says, you are a very geeky person. So there's a machine that I can ask questions, and I get an answer, and it's for free. It's an API that all of us can use out of the box and include it in our systems. Isn't that great? And it seems to be very clever. But to find out if it's clever, I asked some more questions. And those of you who are interested should ask more questions. Please Google for that, it's very funny. For example, what's an API? I asked Ginny. And Ginny gave me an answer, and it's the answer from Wikipedia. So Ginny has a lot of data that it got pushed when it was trained, for example, Wikipedia data, but also other data that it can learn from and answer my questions based on a standard text, on a handwritten text, and this is for free. So another example is I asked Ginny, Ginny, how do you work? So of course, I want to know how Ginny works. And Ginny said, I read what you say, and then I compose the best reply I can think of. So again, this looks very smart. And this was just a short example of what machine learning can be and how we can use it, and how all the startups here also can use it to analyze their data, and how also Trumpf can use it to analyze their data. And that is something that we can use out of the box. But very often, and that is what I want to talk now about, very often the problems are very, very specific. So here we have a standard problem. I ask a question and I get an answer. But often in the business world, it's very, very specific. And here I brought two specific cases for you, two images that you see. So on the left side, you don't understand, of course, what it is, but I will explain you. On the left side, you see something from a project that we could also do, is you train a model, a statistical model, with the machine behavior. So you know how the machine behaves based on sensors that you plug to the system. So I know, for example, at this moment, at moment X, I know how the machine behaved, what the status of all these different data sensors was. And with this information, I can train a model that it learns how the machine behaves. And then, which makes it very smart, I can also give it additional information about, for example, when did we have problems? When did we have problems with the machine? So the model can learn the correlation between the behavior of the machine and the problems that occurred at the same time. And on the left side, you see something. There is the blue part shows what the error rate over time was. And the yellow part shows what our model that we trained generated. So our model that we trained with machine behavior comes close to the real problems that we could measure. So statistical models based on trained data, that is machine learning, and that helps, for example, to predict problems with the machines. And that is, of course, a scenario which is very important when we talk Industry 4.0 and when we talk about the Internet of Things. Another example that I showed earlier, here again a chart about how we can cluster data and how we can learn from the data. And that is in our company the first step that we do, we explore the data. Because often you have a hypothesis and you think, okay, with this data that we collected, we can do this or that. But then over the time, you learn more from that, and then you find out, oh, okay, so maybe we can switch a bit and we should change the business case a little bit and then come closer to something that we can really solve with the data. So it's about using the data, generating on the one hand, but about using it and understanding it. And this is the process in our company, how we do it. And it's here in this case very simple. Normally it's a bit more, but I wanted to make it very easy to understand. So in the beginning, all the projects, and we work as a service provider, on the one hand doing cloud computing, and on the other hand internet application development, but also data science. So we start with ideations with the customers, because we need to find this business case, and often it starts with workshops, for example. And then we think, okay, to solve this question, for example, for an industry company who have a lot of machines, we start to collect sample data, so data pool creation. We create a data pool with, for example, all the log files from all the machines and maybe some weather data to correlate the machine data later with weather data, and put all that in one source. It can be in the beginning sample data. And then we do the explorations. And there in this phase, also machine learning comes in, but also it starts with simple statistics. So doing, for example, plotting some graphs about getting some insights and getting some understanding of, for example, what was the error rate of the machine in the past. And then it comes, and then often a technology switch happens. So then we, after the exploration that we did, and when we found out, okay, we can do this and this and this with the data, then we bring it to an automation mode. But for automation, we have to use what we learned in advance. And often, when we do then when we build the software, when we build the data science product, the data product that is used, for example, to monitor the machines, we very often cannot use standard models or standard APIs that solve standard problems. Then we have to use our specific trained statistical models that we build in the first phase. And that is something where I decided to make this talk about, because I find it very important that especially the people who work in the data science field and people who want to do more with data, we have to think about when can we use standard APIs, standard software, and when do we need to build something by our own. And especially when it comes to great data analysis, then we have to think about building our own models and building our own software that we can analyze the data and that we can get as much out of the data as we can. Then after the automated analysis, which means, for example, we have now the software that is 99%, that has 99% availability within the company, and that maybe runs not only on 2 machines but on 100 machines, that do data science every day, every hour, every second on that. A monitoring tool that, for example, monitors data in real time, that we heard before. That is done then afterwards in this automated analysis. And then it's, of course, about visualization. And that we heard about the interfaces. That's also important. And I'm very curious about seeing how these companies here are solving that, how they provide it. Afterwards, also in the fireside chat, because in the end, the data has to be used. We can have the best models and we can have the best analysis. We can do the greatest data science, but in the end, the people in the company have to use it. That's why it's also very important. And then finally, running that system and integrating it into the processes. And that is something that is not the fancy part. The fancy part comes in the beginning, where we do all this data exploration, etc. But in the end, it needs to be fully integrated. And that is often, especially in a company that maybe haven't done that much data science before, where then it gets often a bit tricky and where it takes some time, because the people have to be adopted to that, the system has to be used, and it has to be integrated in often these fully complex systems. And that's why we in our company, and I think also other companies, and I think also the companies that we hear afterwards, have to do consulting. So it's not about providing not only about providing a platform and providing a software, but also about consulting the company that this system is built for to be able to address this specific, unique needs. This is our company. We are based in Berlin. If you have any questions, please ask me afterwards. We do data science, but also other great stuff. And I will be here, and feel free to ask me. And as there's a clock, it's 1 minute left, and I want to use this chance to get some questions from the moderator. Thanks.
Ciao.